Hello guys, so today we are going to discuss about binomial exponential. So before we start about this, first we need to know about Pascal's triangle. So this is Pascal's triangle. Why is it triangle? Why do we call it as triangle? Because it is in the shape of triangle. Now, so we start with 1, after that this one is 1 and 1. After that this one is 1, and then you add 1 and 1, then you get 2. Then you always end with 1. Start again with 1. So 1 and 1 is 3. 1 and 1 is 3. Then always end with another 1. Understand? So by continuing it, then you will get this one start with 1. 1 and 3 is 4. 3 and 3 is 6. 3 and 1 is 4. And then this one is another 1. Okay? So by using the same method, you can continue finding 1. 1 and 4 is 5. 4 and 6 is 10. This one is another 10. This one is another 5. And then this one is 1. Okay, so this is it. This is the Pascal triangle. So if I continue with another line, 1, 6, 15, 20, 15, 6, and 1. Now, when do we use it? Now, this one always start with the power of 0. So a plus b with the power of 0. And then this one is for the power of 1. A plus b to the power of 1. This one is for the power of 2. This one is for the power of 3. And this one is the power of 4, and so on. Understand? So this one is power of 4, power of 5, power of 6. So what does it mean? Meaning, when we try to find, when we expand something, for example, the easiest one, the one that we have been learning all this time, which is a plus b squared. Now we know it by heart that a plus b squared equals to a squared plus 2ab plus b squared, right? Which is a plus b squared, we follow the second line. So the 1 put here, the 2 is over here, so this is where it comes from. 1 is over here. Okay, so this is it. Now how about when we want to find about a plus b cubed, a plus b cubed. So what does it mean? So we can use the coefficient to help you. A plus b cubed is using the 4th line. Okay, so a plus b cubed. So we start with 1, the coefficient of 1. Then a to the power of 3, b to the power of 0. Okay, then plus with, then take another coefficient, which is 3. Then we take 3. So a to the power of 2, b to the power of 1. Plus with, then we take another coefficient, 3. A to the power of 1, b to the power of 2. And plus with 1, a to the power of 0, b to the power of 3. So it's the pattern that you can see here. If you can see here, this one simply follow the coefficient, okay, given in the Pascal triangle. Now, about the coefficient, then we can see this one is 3, 2, 1, 0. So it keeps reducing. The first one keeps reducing. And the second one is this one to the power of 0, 1, 2, 3. Then the back one is increasing until it meets the final one, which is 3. Now, and then if you pay attention, if you see here, 3 and 0 equals to 3. 2 and 1 is equals to 3. 1 and 2 equals to 3. 0 and 3 equals to 3. So the sum of the index always is the sum of the index in the front. Understand? So after that, what is the next thing that we can do? Now, so for example, using the same logic, then we can find the one for a plus b to the power of 5. Now, so if to the power of 5 means that we are using this one, right? This is it. Okay, so again, just do it as usual. So start with the coefficient. The first one is 1, a and b. Remember, this one is 5, this one is 0. Plus with the next coefficient is 5, and this one is a4, b1. Plus with the next one is 10. So 10, a3, b2. Plus with 10, another 10, okay, which is a2, b3. Plus with the next one, yes, you get it correct, is 5. Plus with 5, and after that, A1, B4. Plus with the final one is 1. So A to the power of 0, B to the power of 5. So what does it mean? Now, B to the power of 0, everything to the power of 0 is 1. So 1 times 1 is 1, right? So it will be A to the power of 5 plus with, then the second one will be 5, A to the power of 4 plus with, this one is 10, A cubed B squared plus with, then the next one will be 10, A squared B cubed plus with 5, A B to the power of 4 plus with, and this one will be, anything to the power of 0 is 1, so it will be only left by B to the power of 5. So this is the expansion of A plus B to the power of 5. Now, another thing to remember is if this one is the power of 5, okay, if this one is the power of 5, there are 1, 2, 3, 4, 5, 6. There are 6 members in total. If this one is the power of 3, there are how many members in total? Let's count together. 1, 2, 3, 4. So meaning, if something is to the power of, for example, 7, then you will expect how many? 8. There are 8 members of that. When you expand it, there will be 8 of them. 1, 2, 3, 4, 5, 6, 7, and 8. Okay? Now, and then after that, so if there are the next one to remember is that how about if we are looking for A plus B to the power of 20? Then this will involve the bigger number, right? Such big index. So how do we find it? Now, let's go back to Pascal. Okay. First thing to remember is this one is the same as C, 3 combination 0. This one is 3 combination 1. This one is 3 combination 2. Sorry. Okay, my bad. So, followed by this one. Okay, this one is to the power of 2, right? To the power of 2. So, this one over here is 2 combination 2. This one is 2 combination, sorry. So, this one is 2 combination 0. 2 combination 0. This one is 2 combination 1. This one is 2 combination 2. Now, how about the one to the power of 4? To the power of 4. So, this one power of 4. So, we can assume that this one is 4C0. 4C0 you will get 1. Then this one is 4C1. You will get 4. 4C2 you will get 6. 4C3 is 4. 4C4 is 1. Okay? So, you can find the combination to get all the numbers afterwards. Okay, so by using the same logic, so we can find A plus B to the power of 20 very easily. So using the same logic like we say, so the first equation is 20, C0. Okay, and then this one, A to the power of 20, B to the power of 0. Plus with, now the second one will be 20, C1. So A to the power of 19, B to the power of 1. Then the third term will be 20C2. A to the power of 18, B to the power of 2. And then add with, okay, let's try another one. So the next term will be 0, 1, 2. Yes, you guessed it already. So 20C3. So A to the power of 17, B to the power of 3, and so on. Okay, and then if there are 20 of that, it means that we expect there are 21 of the counting going on. Okay, and then the last one would be 20, C20, A to the power of 0, B to the power of 20. This will be the final term. Okay, so if there are 20 power of 20, so you will expect there will be 21 terms. Okay, 21 terms. So 1 term, 2, 3, 4, up to the final one is the 21st term. Okay, and then if you pay attention, so the detail is that if you see here, these and these are always the same. Okay, if this one 1, this one is 1. If this one is 2, this one is 2. If this one is 3, this one is 3. This one is 20, this one is 20. And then when we add up, 20 and 0 will be this one. The sum of this and this will always be 20. The sum of 18 and 2 is always 20. And then the 7 and 3 is always 20. Okay, according to the index. Then another thing to remember is that if you are talking about the first term, remember the first term start with 0. If you are talking about the second term start with 1. The third term start with 2 and so on. So if we are looking for, in this case, so if we are looking for the sixth term, then even without make it a long working, so we can always see, remember the sixth term is this one is 5, 20. So a to the power b. So again, this and this is the same, and then this one will 15. That's it.